All right, welcome back. I'm going to do part 3 of what was supposed to be a single part look at the Bazel source code. I noticed in my past couple of videos that there were some glitches around the video. I think I pinned that down to an encoder issue or a firmware issue with the hardware encoder I was using. So I switched back to software encoding. Hopefully that issue will be taken care of. And at some point, I guess I'll see if I can make Linux and OBS properly encode video. But I don't know anything right now about video hardware, so I'm not quite equipped to tackle that at the moment. So I'm back at the Bazel source code. This should be more or less where we left off. Perhaps not exactly, because I did close the window and then restored it. But let's see where we are. So this is just the source. Let's get rid of that. Okay. There might be some interesting stuff here, but we'll close this for now. This is just a directory. More directories. Okay, so now we're in DevTools/build, and I guess let's take a look at Skyframe, and then actually let's go back to lib. So actions we looked at before, analysis we looked at before, the Bazel directory we've taken a look at. I think we've looked a little bit maybe at commands. We haven't looked at coverage, commands and coverage. And I don't know if we looked at repository or rules. And so let's at least see what's in here. We have a sync command, fetch.text. I don't know why there's a text file. We have a fetch command. I'm guessing fetch command is going to fetch things like over the network. It's basically going to curl things. See, fetch command. Fetches external repositories, which is so fetch. All right, we get a pun in the code comments. Kind of a callback to what, like Mean Girls? I think Mean Girls, right? 2004. All right. So how do we actually fetch? I guess that's a somewhat interesting question. Let's see. Actually, there's some interesting logic in here. So we have this function exec, which I assume is part of the API for Blaze command, the interface Blaze command. And exec is going to return a Blaze command result, which is a pretty generic sounding thing. And it'll do some options checking here. Loading phase threads options. So this is something more about options. We're going to try some stuff and then catch errors. And what are we trying? We're going to try sync package loading with env, which is some sort of environment. We have a repository mapping, get Skyframe executor, get main repo mapping, and main repo target parser. So that sounds to me like setup. We're going to query for dependencies. Querying for all the dependencies of the targets has the side effect of populating the Skyframe graph for external targets. Okay, so we're going to query so for all of our targets unmodified, I'm going to assume means local targets. So we're going to query all the targets, and as a side effect, that's going to populate the Skyframe graph, which might be the same as building that graph for all the external targets, and which will require downloading them. The JDK is required to build everything, but isn't counted as a dep in the build graph, so we add it manually. Okay, that makes sense. So everything depends on the JDK, presumably because this is Blaze or Bazel is written in Java. Let's see, we've got a new query environment. Keep going. Maybe that's, I don't know what keep going is. I'm guessing that's maybe how to handle errors. Just keep going. We're going to parse the query. Evaluate the expression. Evaluate query. Does this actually do network operations? I'm not sure. But if query eval, if the query evaluation result is successful, we are going to report some stuff and do some other stuff. But where's actually the network code? Is that in the thing I just glossed over? Okay, here we go. So it's the query eval step, right? So where is that? Try query evaluate result. So query env is going to evaluate query of the expression, and we get a thread safe output format callback, but doesn't seem like we get anything network related. So maybe all of that stuff is in the query library. So let's take a look at that real quick. We have exec, but I think we want /query, right? Here's query 2. That looks promising. So we have a query, common, compat, C query, engine query, and a bunch of files. Sky query environment, Sky query utils, and maybe in query. I'm not sure. This, I think, could be its own, you could spend an hour going through all the query stuff. And I think that maybe at some point it makes sense to do that. I've been going on kind of a tour of some compiler-y things. I'm thinking that maybe the Bazel query operations might be part of a series on query languages, things like SQL or Sparkle or GraphQL, kind of looking at those together and then getting a sense of how different query engines do their thing. So I'm not going to maybe go too deep into this. I was mildly curious to see if I could find like what dependencies they were using for network. I guess I can search for HTTP, but yeah, no results in the code. I guess I could search for curl. We've got commits. And I think these are just like testing things. So what about fetch? No. At some point, I'm going to have to stop trying to rely on GitHub search. I'm just going to have to download these repositories. But I don't have a lot of time today, so I'm not going to do that now. Okay, so here's coverage. We have coverage report module, coverage args, and coverage report action builder. But I guess this doesn't actually do the coverage. It seems like there's not enough here to actually compute coverage. I'm guessing that coverage is computed by something else, but we can at least look at what the module does. And when I say something else, I mean most likely like the compiler, or in the case of C++, or the Python framework in the case of Python. So Bazel's not going to compute coverage. Bazel's going to consume, I guess, coverage computed by tooling lower in the stack. Add support for coverage report generation. Okay, so this is just coverage report generation, which is useful. The Bazel, I used the Bazel coverage reporting a lot, and it was useful, but I don't think it's doing any super interesting, deep technical work. Okay, so what do we have here? We have a repository, a cache, a downloader. That sounds like it's going to do network stuff. Check content length, check sum, content length mismatch, delegating downloader, download manager, download progress event. Here, okay, HTTP connector. Hey, look at that. Let's see. Okay, so what? I'm looking at the imports. We've got JavaNet URL connection. So I think URL connection, HTTP URL. So I guess it's just using Java .NET stuff, which makes sense. Yep. Okay. So they're not using any sort of like fancy library, and who knows? This file may have, this might be based on some HTTP Java-based HTTP downloader that goes back to the beginning of time for Google. So it would, in that sense, maybe make sense that they're not using like a more. I don't know the Java ecosystem. I know for a while there were things like OK HTTP that was used a lot in Android, but they're not, as far as I can tell, they're not using stuff along those lines. Okay, so here's more download manager. I think I've gotten what I needed out of looking at the download stuff, which is I just wanted to see what they were using for fetching. Okay, so let's close the download stuff. Here in repository, this looks like this is going to do things like manage external repositories, and also whatever repository functionality is needed for your current workspace. I'm going to close that out just because there's more complicated stuff that Bazel does, and I want to make sure I at least have a sense of where all of that is located. So here's Bazel rules. Let's totally look at genrule actually. And then we've got prerequisite validator, Bazel rule class provider, Bazel rules module. We should look at the rules module. CC rules and generic rules, Java rules, and yeah. So I think that'll probably exhaust the time I have. And then it would be nice to look at Skyframe. Somewhere I had Skyframe open. Here's commands again. Here's rules, which is where I was. Here's Skyframe. So let's pull Skyframe out and just see if anything. So there's lots and lots and lots of stuff here. Walkable graph. Hey, what's a walkable graph? Sky value. Sky key, if I remember from last time, or that is yesterday, is like a name, like a way of labeling nodes on a graph. Node entry, node batch, node entry visitor, which I guess indicates that they're using the visitor pattern in some way. Immutable diff, evaluation result, eager invalidator, cycle deduper, and cycle detector, I think should be straightforward. CPU heavy sky key. Okay, so I'm going to look at a little bit of this at some point. I might come back and do a look just at Skyframe. But at least I can familiarize myself with what's going on here. So a walkable graph is a read-only graph that exposes the dependencies, that is reverse dependence, and value and exception, if any, of a given node. Certain graph implementations can throw interrupted exception when trying to retrieve node entries. Okay, so a walkable graph returns the value of the given key or null if it has no value due to an error. So what makes it walkable though? Okay, so we have get, the functions are get value, get successful values, get missing and exceptions, get exception is cycle. And the cycle takes a key. And I guess the idea is you're going to see if anything is a cycle. So it's going to return true if the node with the given key depends on a cycle. Okay. Returns false if the node does not depend on a cycle. Great. Get direct dependencies, either taking an iterable or a key. You can get reverse dependencies. and get value in R depths, which I assume R is for reverse dependencies. Okay, cool. And get all keys for testing. Great. All right, what is a sky key? A sky key is effectively a pair of type name that identifies a Skyframe value. Type and name. Is type like the Java type system? Sky key implementations are heavily used as map keys. Thus, they should have they should have fast hashcode implementations and cached if necessary. The same sky key may be created multiple times by different sky functions requesting it. And so it should have effective interning. I don't know what interning is. The sky key may be created multiple times. What is interning? Intern jobs. Okay, well. All right, so there will likely be more sky keys on the JVM heap than any other non-native type, so be mindful of memory usage. Okay, so these are used a lot, is basically what it's saying. A sky key extends serializable, so it's serializable, and we have a reference to a sky function name. All right, and what do we see? We have is shareable, supports partial reevaluation, gets sky key interner. Okay, so there's canonicalize, returns the canonical instance of the sky key if found in the pool. Okay, cool. An extension of the weak interner. So here we have interner again, sky key interner. An extension of the weak interner, which contains an alternative and static global pool container in addition to a weak interner and supports removing sky key from the weak interner. That's cool and all, but what's an interner? Once again, I have to convince it that I mean my search terms. Okay. This is just GitHub, but are you going to tell me what an interner is? Google comment collect interner. Oh. I didn't mean to open that as a link. It's Guava. All right. So it's similar behavior to string intern for any immutable types. Chooses and returns the representative instance of any of a collection of instances that are equal to each other. Two equal inputs are given to this method. Both calls will return the same instance. So it's kind of like choosing a representative of an equivalence class, it sounds like, which is actually pretty interesting, but I'm not going to dig too deep into it right now. Okay, so that was sky key. Sky function is a machinery to evaluate a single value. The sky function implementation is supposed to access only direct dependencies of the value. Yeah, okay, that's great, but I want to know what it does. Hang on. Okay, so we've got a function compute. When a value is requested, this method is called with the name of the value and a dependency tracking environment. This method should return a non-null value or null if any dependencies were missing. Okay. So compute is going to return a sky value. You're going to call it on the sky key and the environment, and you're going to get a sky value back. All right. Extract tag extracts a tag or target label from a sky key if it has one. Restart returns sky value. It's a sentinel type for compute to return, indicating that something went wrong and the evaluation returning this value must be restarted. And the nodes associated with other keys in rewind graph must also be restarted. Okay. So it's like you're not like resuming a computation, but it says you have to do it over. And then we have an interface environment, and we have get value or throw, some more get value stuff. Okay. cycle deduper. This is going to dedupe C candidate cycles of size O of L and OCL. So I guess C is a number, right? Time and memory in the common case, and O C squared times L time and OCL memory in the extreme case. All right. Two cycles are considered duplicates if they are exactly the same, except for the entry point. For example, A to B to C to A is considered the same as B to C to A to B, because they're, I guess, it's just a permutation. So cycle deduper. It's got something that, like a set, I guess, basically that checks whether something's already seen, and equals with single loop from. Okay, so that's actually relatively, that kind of looks like it might be like a programming exercise, but in the API of Bazel or whatever. CPU heavy sky key is just an interface. An empty interface used to annotate whether the evaluation of a sky key contributes significantly to the CPU footprint of Skyframe. So this is mainly used for an analysis, I guess. And a pre-computed value, a value that represents something computed outside of the Skyframe network. Okay, so this is for importing things that are maybe computed offline or with some other system. All right, cool. So that's a little look into Skyframe. So we're back at Bazel rules, and I'll take a quick look at these files, and then I have to jet. Okay, so here's the CPP rules. I don't want to start here. I want to start with the rules module. So let's take a look at rules module. And this looks pretty big. Yeah, look at that. Okay. So there's some deprecated stuff. Bazel rules module is going to extend Blaze module, which is not surprising. Let's see. We've got some options. Build graveyard options. These fields have no Java doc by design. This is where deprecated options used by both Bazel and Blaze, but only needed for the build command go to die. Okay. All right. So a lot of this looks deprecated, I guess. Here's more deprecated options. This is where deprecated options which need to be available for all commands go to die. Is this just all deprecated? This whole file? Maybe here is where it starts. Okay, so we've initialized rule classes. It's going to do some workspace stuff and implement before command is going to validate remote outputs mode. And on init, it's going to add a sky function. cc Skyframe f do support value sky function. I don't know what that does, but it's going to add some sky function. Get command options. Register action context is going to register Java compile action context and Java compile action context. All right. Validate remote outputs mode. That's some output stuff. Okay, so once you get past the deprecated stuff, there's not a lot here. It's going to there's a relatively minimal amount of configuration, I guess. So here's CC binary rules. Here's Java. And then here's other CC rules. So how is this different from, how is CC rules.java different from rules/CPP? Let's take a look at CC rules.java. Okay. And there's not much here. We're going to add workspace file suffix, and we've got requires. When we init, we're going to add a bunch of stuff, such as CC toolchain rule, CC toolchain suite rule, blah 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 blah. So this is basically just config, right? All of the real work is done in the implementation of the modules, which makes a lot of sense. That seems like a good strategy. So generic rules I'm interested in, and then we have this Java rules thing. Is this just going to be the config for Java? Yeah. Okay. So this looks like Java rules.java is like a config, and then maybe the real work happens. Oh, we have Bazel general for Java and Bazel general for Java, and then what's going on here in CPP? C binary rule, import rule, library rule. And I think that these have mostly been, or at least they're trying to move these out of the Bazel codebase, maybe? I don't know. This rule is implemented in Starlark. This class remains only for docgen purposes. Okay, so this has been moved to Starlark, but I guess at one point it was probably actually implemented in Java, maybe. So I guess there's not a whole lot of reason to look at it. Here's the rule definition for CC import. Is this also implemented in Starlark? Maybe I can look at the commit. Move several rule classes to top-level files. Clean up code, refactor, remove statement. This is most recently, the note that this is implemented in Starlark was added by a rollback of a commit. Let's see. Can I, all right, whatever. All right, let's take a look at CC import. We've got get metadata and build, and we're going to require configuration fragments from cpp configuration.class, and then we've got some, whatever this is, some sort of string, a comment. Okay. I'm guessing all of the CPP stuff is just in the new Starlark implementation. And then what do we have here? We have CC module. Okay. This looks like it has stuff to it. It's a module that contains Starlark utilities for C++ reports. So this is like a utilities file or folder. So what do we have? We have get semantics, returns Bazel semantics.cpp. We have linking outputs, compilation outputs, and some other stuff. Okay. Cool. I'm not sure really what any of this does, but I think in what is Bazel CPP semantics? That's CPP. Let's see if there are any other. Okay, so here we go. Rules.cpp / CPP semantics. .java probably. Bazel CPP semantics. It's going to implement aspect legal CPP semantics. Okay. And what is actually going on here? We've got provider keys that tell us things like parse canonical unchecked. We've got this function language that returns language. Is language set anywhere, or is it something you like pass in when you call the constructor? Language.cpp. Okay, so it's just going to tell you that you're using CPP. Finalize compile action builder, and it's going to check if the language is CPP, and if so, it's going to call configuration get fragment. I don't think I've looked at what a fragment is of the CPP configuration class, and it's going to call action builder get source file. And then action builder is going to call add transitive mandatory inputs with some configuration that checks whether it's a tree artifact and has something about use specific tool files. And it's checking, I guess, whether it's assembling. And if so, it's going to get assembly files. Otherwise, it's going to get compiler files. And then at the end of, I guess, this large if else thing, it's going to get all files if, I guess, if all the other conditions are false. And it's going to set whether we should scan the includes based on some settings, requested features, and whether it's a type assembler or a CPP module. And otherwise, what is the first if condition? So if the language is not CPP, then it's going to do something else. It's going to add a transitive mandatory inputs toolchain get all files, including libc, and set should scan includes to false. I'm not sure under what conditions language would not be language CPP if we're using the Bazel CPP semantics file rule configuration. I'm not sure what to call it. Okay. So we've got things like, should we check headers like strict, I guess. Needs include validation if language is not equal to language.object, I guess Objective-C. And like get CC shared library info. So this is just, this is kind of like encoding in code a bunch of different cases that can happen based on like how you've configured things and based on like, are things assembly files? Are you calling this from Objective-C and stuff like that? Okay, so Bazel CC test rule, I don't think we need to look at that. Bazel CPP semantics, I think we just looked at that. So let's look at at the implementation of general rule. So it's going to extend general base. Is stamping enabled? Has stamp. All right, so there's not much there. Is there anything here? So Bazel general rule is going to extend rule definition. It's got this function build, which returns a rule class, and it's going to set output to gen files. It's going to add some attribute general setup, and we can get metadata, and then there's a code comment. Okay. Here's generic rules.java. And this is a set of generic rules that provide miscellaneous capabilities to Java. Public class generic rules. Okay. And we're going to add a rule. So when we init, we're going to add rule definitions, environment rule, alias rule, Bazel file or group rule, test suite rule, gen query rule, label build setting rule, label build flag rule. And then we're going to try to add a workspace file prefix using whatever this thing is doing. And it says in builder, add Starlark accessible top levels, built-in's dummy. Okay, so there's not a lot going on there. Let's take a look at this file, toolchain rules. And this is just going to add the toolchain type rule, gen rule, base rule, Bazel general rule. All right. So in rules, I guess there's not a lot going on. It's, if I'm understanding correctly, it's basically like all configuration. Now some of it, so that was what lib/bazel/rules, and here's just lib/rules without the Bazel. I guess we can look at this to see if there's anything majorly different. Like CC module. Okay. I'm not sure if this is majorly different. I mean, we're doing stuff with compiled binaries. Get link build variables, as string nested set. Okay. It seems like maybe this is the Meteor directory. Are gen rules in here? General. I'm going to look at general, and then I'm going to head out. General action, general base rule. Let's close these other ones. Okay, great. So general action is going to extend spawn action, and we saw yesterday that most actions should extend spawn action or some other one whose name I forget. So that's all well and good. And what is the general action going to do? Let's see. All right, that nothing's jumping out at me in the constructor. So before execute, it's going to check if you want to track source directories flag. And if not, check inputs for directories. All right, and after execute, it's going to check output. So I guess before it's going to check inputs, after it's going to check outputs. Here's general base. This looks like it has more logic to it. So it's going to, general base implements rule configured target factory, a base implementation of general to be used by specific implementing rules which can change some of the semantics around when the execution info and inputs are changed. So is stamping enable returns true if the rule should be stamped. General implementations can set this based on the rule context. I don't know what it means to stamp. Determine command type and attribute. And it's going to return a pair of command and string. And it's going to look at the OS. It's going to special case Windows. And it'll look at attribute map. Is attribute value explicitly specified command bash? In which case it's going to say that it's a bash command. Okay, so yeah, so the special casing of Windows is Windows PowerShell. Is this a Windows PowerShell command? Is it a Windows batch command? Is it a bash shell command? That's the sort of thing this is doing. So this is determining like what kind of shell script we're looking at. What else do we got? We've got configured target. Create is going to return a configured target. And what's it going to do? So if files to build is empty, then we're going to do some stuff. If it's not empty, then we're going to get executable with type Boolean and checking some stuff is empty. And then the attribute, so there's some attribute error. Executable. If generals produce executables, they are allowed only one input. If you need the executable equal one argument, then you should split this general into generals producing single outputs. Okay, so a general can only produce one output. So what is this test doing? It's like if it's executable and the files to build is not empty and it's not a singleton. Okay, then we just display that error. Great. All right. Let's see what else. And then, okay, so we're looking at create. It's going to check whether you're producing more than one output. And if you are, it's going to tell you can't do that. Then we're going to determine command type and attribute by passing in a rule context. And we're going to create this label map by collecting sources. This is something about stable ordering, I guess, maybe ensuring that resolved sources builder has a stable order. And for each of the label map values, we're going to call resolved sources builder add transitive. I'm not sure what that is doing. And then we've got this resolved sources, which is a nested set. And we're going to get them by resolved sources builder.build. So this is kind of, it seems like it's accumulating inputs and outputs, that sort of thing. And then we have the command helper. The command helper class makes an explicit copy of this in the constructor. So flattening here should be benign. Okay, that's just a comment about what it's doing. So it's got some command helper and it's going to, I guess, maybe flatten the label maps. Label map, entry set, stream, collect, to immutable map entry get key get value to list build. If rule context has errors, return null. So we now check the rule context, I guess, after doing all this work. And then we have some command type stuff, a base command, and we're going to expand template variables and functions, which I guess, like, if we're in Bash, then we're going to do things like expand the Bash template and functions. Heuristically expand things that look like labels. So there's some heuristic here. So if rule context attributes get heuristic label expansion, then we're going to set command to command helper expand labels heuristically. Okay, well, that's not very illuminating because it's just calling out to a function, but that's fine. And then there's some special casing if it's Bash. We're going to add the general environment setup script before the actual shell command. So it's going to, the command is going to source a file of the general setup script. So it seems like it's adding source, a call to Bash source, to whatever command it's creating. And then it seems like we're about ready to start executing. So we're going to, from the rule context, we're going to get message. And if it's empty, I guess, we're going to make the message executing general. Otherwise, we're going to use the message attribute. And some more label stuff on a progress message. Execution info is going to be from a new linked hash map. And we're going to execution info put all target utils get execution info from the rule context. If it's local, we're going to put local execution, and we're going to call rule context get configuration modify execution info with general action mnemonic. I still don't really know what a mnemonic is. We've got more stable order stuff, more transitive stuff, special casing for Bash. And this is something about the general setup being a prerequisite. Error out if you have errors by returning null. Some special casing for batch. It's going to use general script.bat. PowerShell is going to use general script.ps1. And then for Bash and default. So Bash is essentially the default. We're going to get the sh toolchain for the platform, and have some more configuration stuff, and build Bash command constructor, and maybe execute it. Build command line with the command helper, check for stamping, and then we're going to register an action, general action, rule context get action owner, blah, blah, blah. Let's see, argv. Yeah, so we're going to pass in some of the stuff we just computed, like argv was computed here, and constructor is somewhere. Let's see if we can find where constructor is used. Oh no, I lost my place. I think I was pretty... Okay, so we compute a constructor. Okay, and argv takes constructor as input. So argv in some sense is including the information from constructor. We have a run files provider, and that's going to no run files provided if not a data dependency. Otherwise, we only need to consider the outputs of a general. No need to visit the dependencies of a general. They cross from the target into the exec configuration because the dependencies of a general are always built for the exec configuration. Okay. And then we're going to return new rule configured target builder with this rule context, files to build, etc. So this is just like all of this is kind of like just a fancy way of like executing a bash or PowerShell or Windows batch command in the world of Bazel, where you need to have certain it needs to hook into the various things that Bazel does, like creating a graph and knowing what its dependencies are. And it also needs to make sure that it's like executed in the proper environment and is it in the sandbox, etc. And then we have some like lookup functions. Okay, expand singleton artifact. And that looks relatively straightforward. All right, so that was actually somewhat illuminating. At least they have a sense of what the general is doing. And I'm going to go ahead and drop off. Thanks. Bye.